So this only works for limits where the numerator and denominator are both going to 0. Well, we can stretch it a little bit in just a minute, but for right now, it's just for limits that are 0 over 0, or what you might call an indeterminate form. There's not enough information alone to figure out what 0 over 0 should be. We need to be very precise in the way that we use this technique. The reason why it works is exactly because both of these function values are equal to 0. So when I calculate the limit of their derivatives, right? I'm looking at this formula, the limit of f prime of x divided by g prime of x. If I was able to use direct substitution there, I'd get f prime of a divided by g prime of a. Why should that be equal to the limit I started with? Well, I know that each of these derivatives is a limit. A derivative is the limit as x goes to the number a. And here I've got my difference quotient. F prime is equal to the limit of f of x minus f of a, all on x minus a. Take the limit as x goes to a. G prime is equal to the limit as x goes to a of g of x minus g of a, all divided by x minus a. So if this quotient is really the quotient of two different limits, and my denominator is not 0, my g prime is not 0, then this will be equal to the limit of this, fairly brutal looking thing. So I've just combined those fractions. And when I go to resolve my division of fractions here, I'm going to multiply the fraction on top by the reciprocal of the fraction on the bottom, which gives me, well, I'm looking at the limit as x goes to a of f of x minus f of a, all on g of x minus g of a. Is that good so far? So in general, this should be true for any differentiable functions where g prime is not 0. But I know a little bit more about my f and my g, specifically because of the problem that I have. I'm only using this technique because both f of a and g of a are 0. If both of those function values were not 0, well, I could just do my division and I could just use my direct substitution property. I wouldn't even have to use L'Hopital's rule. If one of these things were 0 and the other wasn't, I'd either have 0 divided by some constant, some non-zero thing. I'd know my limit is going to be 0 then, again by direct substitution. And then if my numerator was some non-zero thing and my denominator was 0, well, I would say that limit diverges. So I have extra information because I only use this rule when both f and g are equal to 0 for x equals a. Well, I'm going to use that information right here in this expression. F of a is 0, so my numerator is really just f of x. G of a is 0, so my denominator is really just g of x. I'm still taking a limit. So this limit as x goes to a of f of x divided by g of x. Remember, this is my indeterminate form, my 0 on 0 that I can't figure out. Well, it'll just be equal to f prime of a divided by g prime of a, as long as that limit did exist. Let's look at this in terms of another problem. So here I have the limit as x goes to 0 of e to the power x minus 1, all on sine of x. And I know that both the numerator and the denominator here are going to 0. So this is another one of those indeterminate forms. And we can use L'Hopital's rule here. Both of these functions are differentiable. We know how to take their derivatives. So I can try calculating this limit instead. The derivative of e to the x minus 1 is, of course, just e to the power x. The derivative of the sine of x is the cosine of x. So now I can try my direct substitution, and it actually goes through this time. So if x equals 0 here, my numerator is going to be 1. My denominator is also going to be 1. So the original limit has to be 1.